heat pumps are, of course, the leading means of low carbon home heating, and there's 67,000 heat pumps expected to be installed this year. But by 2028, the government plans for 600,000 per year to be installed. This is scheduled to grow massively, and there's a bit of a shortage of understanding and people to install them, but we think we're going to learn a lot, and certainly different from gas boilers, as Warren will explain. After his talk, we're going to have questions, so please put your questions in the chat. At the bottom of your screen, you've probably got a speech bubble. And or along with, if you have advice or comments or links you want to share, put those in chat too. And then Michael Goodhart and Anne Miller will briefly then give you two homeowners' experiences with heat pumps, just to get another picture of this, followed by more questions and discussion. And that's the plan for the next hour. So Warren Pope is well experienced in retrofits and energy in buildings, and he's the retrofit project manager delivering some local retrofit services through the Eastern New Energy Project. I'll put the links to this in chat in a minute. Being delivered by RetrofitWorks, which is a co-op, and Warren will explain more about this. So over to you, Warren.
Thank you. Good evening, everyone. Let's just get up. There we go. Hopefully you can all see a presentation.
Yeah.
Oh, excellent. Yes, so I wear two hats with RetrofitWorks. I'm managing a ERDF funded project, a research collaboration, which is looking at going to the next level with energy efficiency. Unusually it includes private housing, but it's also working with non-domestic companies as well. Well, there will be if they're a company. But yeah, there is grant funding available depending on what people are doing as a company. We are here to try and help people as a larger project develop new services, new products, and improve efficiency generally around the board. Now, I'm going to be going at a bit of a pace as we go through this because there's an awful lot of information we've tried to squeeze in. At the back of the presentation is my email address. So if you've missed anything or I've gone too quick and you want to know more later, send me an email and I'll get back in touch as soon as I can. I've also got some details about the ENE project, also right at the back of the slide, but I'm not going to go through those. They'll come out in the handout. And then also I've put some reference material in as well to allow for the figures, numbers and stuff that people might want to know, just so it's there. But I thought better to get more content in at the beginning than at the end. So in the initial polls that came around, there was talk about how you calculate the size of the heat pump that you would need for your building in particular. I need to stress that in order to claim the renewable heat incentive, it is important that the guy is a NTS qualified installer and that you have the correct plans. As part of the registration process, they are required to do the heat loss calculations and register the system on the MCS website. Without that, it is difficult to actually size a heat pump properly for the building. More on that later on as we go on. Most important thing I like to say about being the ideal site requirements, and we'll talk about hard to heat homes in a little bit, is that when positioning the pump, try and make sure it's as easy to access as possible for when it comes for servicing. Sometimes they're up on top of a ladder, sorry, on a frame where you need a ladder to reach it. Ideally make it as easy as possible. Typically, an average 3 to 4 bedroom house with around 10 radiators would require probably a combi boiler of about 24 to 30 kilowatts. For an air source heat pump, which would be air to water, an average 3-bed, well insulated would typically use an 8.5 kilowatt. Be around about 12 grand by the time it's done, fitted and installed with all the labour, pipe work and everything else. and potentially would earn a renewable heat incentive payment of 10 grand over 7 years. So it would have a cost of about £2,000 to it, but that will be roughly equivalent to a gas boiler. Now I have made an acronym list at the back of the presentation. So there is the coefficient of performance, which is one of the numbers that's used. And this is probably the most important bit to explain why heat pumps are good for carbon reduction. The heat pumps are improving year after year with a better COP figure to it. But simply put, if you've got a COP of 4, for every 1 kilowatt of energy that you use, you actually generate 4 kilowatts of heat. And that is where the financial savings come from, but also the carbon reduction. For those that don't have a heat pump, typically speaking, if you have a gas boiler, turn it on in the morning and it would take about half an hour to warm the house up. With a heat pump, it can take around about an hour, possibly a little bit longer, depending on how the house is. So with moving over to the heat pump, there is going to need to be just a little change in the way that people live, use the heating and so forth. So having it on for longer and lower, rather than sort of the high burst from a typical gas boiler. The other thing to remember is that most heat pumps have multiple immersion heaters in them to help with water, and they're also there to do with the Legionella clean by heating the water up high. If a heat pump is continually put on to burst, that means all the immersion heaters were coming up at the same point in time. So certainly in the early days when heat pumps went in, as people were using them like a traditional one, and I'm talking 7 to 10 years ago, they actually ended up with an electricity bill that was more than what they had beforehand because of the use of the immersion heaters. All right, where's that moving? There we go. Just some text there. I'm going to leave people to have a read through, and it's there really for when you get the handouts with the slides. With hard to heat homes, sorry, the street parties going down the street outside the window. It can potentially struggle in order to do the heat where if you've got a leaky house. On those occasions, it's worthwhile thinking about having secondary heating, but needless to say, as low carbon secondary heating as possible. I'm a good fan of infrared panels. I've worked with them a lot and I think they work well. And I've recently come aware of another product, which is the Laname heat board. They're actually used in car seats for warming car seats up if someone has a really big posh car. But they've developed the product so it can actually be plastered into the ceiling, plastered into the walls, so you can get a good overall heat coming in the room that you're in. I've not actually experienced go in first. I've only been made contact with over LinkedIn, but it seems an interesting product. It has a very low energy consumption because it works on giving off a low continuous baseline heat. Also with the infrared panels, you can actually get panels which have, for one, Swarovski crystals in, if you have €1,000 to spend on one, or alternatively, you can actually get them as a mirror finish or with a print on, so they can actually be blended in to the background, so they don't stick out quite so much. With the infrared product, it heats solid mass, heats people, rather than heating the air up, and this comes back to the reason for why they're useful as secondary if you've got a leaky house, because it will heat the people rather than the air, and then because it's always heating the people, walls are the surfaces, it will also allow the heat to release later on. If you have a solid wall stone built property, they would actually be quite a good product to use in conjunction, say, as your secondary heating. Just a quick image there from the Laname Heat website. I've put the details in so people can go and have a look if they want to, see what it's like. Although it does cover mostly car vehicles and so forth. Now, with these products here with the photos underneath, that is a demonstration of the different type of infrared that you can get. The print is on the left-hand side. That mirror in the hallway is actually one big heater. And then they can also actually do a mesh that can actually go underneath flooring, either solid stone or parquet flooring. Just other areas as to where they can be combined if needed with the potential for a heat pump. Now we have here roughly all the sorts of different types of heat pumps you can get. I did actually hear while I was putting this together that there is now a hybrid of a hybrid heat pump even, but that's in the early stages, so I'm not worried to include with that. The most common ones that you're going to see will be a air to water air source heat pump. You can also have them so they do air to air, similar to air conditioning, where it warms the air up. You get them either as what's known as a split unit or a monoblock. I have an image in a couple of slides which will explain what the difference is. And there are high temperature and low temperature. My contact that does heat pumps that I talk to on a regular basis is telling me that the industry is moving towards low temp heat pumps instead of the high temp. If anyone is thinking about getting the pump and then going for the renewable heat incentive, generally speaking, the high temperature versions will not perform as well as the low and won't come within the boundaries to gain a payment. With the ground source, you have your coil or a slinky as it's known, or a borehole. Typically they only come as a monoblock. There is the air air and ground to water with the hybrid heat pump. Typically they would be included with another boiler, LPG, oil, something similar. Could even be with natural gas if that were the case. At time of putting this slide together, there was an announcement by Centrica that they are hoping for the government to put something like £35 million in towards working with hybrid heat pumps. That's probably more because they want to keep selling their gas boilers, it has to be said. But there is potential for more grant to be coming around. And then there is the water source heat pump. Not really very many to be seen about. They would mostly be either with a hotel or the more non-domestic, or if there is like a really large stately home as such, that they would actually benefit from using one of those. Now, the heat pump works by compressing a medium for changing the heat, which is in the unit on the side. It draws the warm air in and forces cold air out. Typically with those, the control or the compressor needs to be situated around about 300 mil away from the wall. The air is drawn in from the back and the sides, and then it comes out the front. It is quite common, unfortunately, to actually see these units, especially in a non-domestic area, with weeds, grass, and all sorts of foliage actually growing into them. It's important that they be put in a clear area and sort of kept just regularly tidied, you know, hooving out and just made to keep them clean. An annual service would be a good idea, much the same as you would do with any other sort of heating device. Now, the things to consider for this, which is what I was saying earlier, the picture in the top over here, that is a monoblock unit. What that means is it's doing the compressing, warming the water up in the top bit, and then it's through the pipe out and off. In a split unit, you still have your box on the outside, goes through the wall, but then you have what is the top half of the monoblock actually heating the water inside the building, and then it goes off to a cylinder. So you need more equipment, and also typically the split units are between £4 and £6 grand more expensive to actually fit. If, say, you were in a conservation area and you weren't able to have your compressor unit as close to the house as you would like, or it would be in view, you can move them up to about 30 meters away from the main building. Unfortunately for that, an F-gas engineer is required in order to put the gas in to make sure it's all kept and done safe. And that is where the extra cost comes from, because of the cost of actually employing the F-gas engineer. Again, my contact says they are very hard to find. There are very few, and they have regular work, so it keeps them going all the time. Here we have, in fact, the back of my colleague, who gives me all the information that I need to know. The picture with him bleeding over is really what you'd want to see with a heat pump, keeping all the pipes absolutely properly insulated, all done nice and tidy. And I've since found out that the MTS people have actually asked to use this one as a case study for how heat pumps should actually be employed. Just moving on. That's one important thing which is on the slide. Making sure that there is enough space for the equipment to go in. Ideally, as it says there, printed on the slide, it's either 2 by 2 meters square or 3 by 2 meters, and certainly a 2 meter height inside to allow for pipe work and everything else to go and be fitted. Now, with the requirement for the high insulation is because of the way that they work differently to, or heat pumps work differently to a gas boiler. As it happens, this is an image at one of the BRE innovation houses from about 10 years ago of a hybrid setup where you've got the heat pump and you've got a gas boiler next to it. The gas boilers will normally heat the water to about 85 degrees with a heat pump closer to 45, 55. And that requires that the emitters, as it's called in the trade, or radiators to the normal people, they need to be bigger to allow more heat in for the heat to soak and run through. An example that I use is the radiator I'm sitting next to at the moment is approximately 900 millimeters long. If we were to go to a heat pump, it would need to be increased to somewhere in the region of 1.2 meters, and then also be a double skin instead of a single skin. It's just to make sure that the heat is there and it can get out. Underfloor heating is ideally best because it's really well suited to the lower temperatures for doing the heating. However, if you have a gas boiler and an underfloor heating system, it's still likely that you might have to have your underfloor heating revised, possibly because of the pipe size, but also because it would have been designed to handle water at 80 degrees rather than the lower at the 45 odd. Now, I just wanted to show you on this next slide that just because you might have to go for a bigger radiator, they don't actually have to look horrible. We have this one, and this one, all look really nice from the different ranges. They're really quite good, nothing to be ashamed of. And then I just also wanted to include the picture here of the Sun Amp, sorry, we'll get that back, water heater. It's a product which is new. They've been around for about 12 months. I've not actually seen one for real yet. However, I am doing some CPD training with them last week, and some of my colleagues have actually seen them installed. They've been described as very similar to a small fridge. They can be partnered with a heat pump, and they actually act as a thermal store or thermal battery, if you like, for holding hot water. It works pretty much on an instantaneous case. They have phase change material inside, which enables them to soak up the heat. They can be included with, they can be powered by PV. You can have solar thermal connected to them as well to bring water in. As I say, heat pumps and other devices as well. For the ground source heat pumps, as we said earlier, typically either a borehole or what's known as a slinky. So we've got the two images there in the photograph so people can see what it's like for that. The reason they work well, and in fact the ground source heat pump will give a more stable temperature because the soil retains the heat of the land, typically between 9% to 12% depending on location. Needless to say, it's better if you're down south, not quite so good if you're more up north. And because it has that stability to it, the heating process is more stable than it would be with straightforward air source heat pump, as they are. It works in exactly the same way. You have a medium inside the tubes, which is like an antifreeze mixture which goes around for doing heat transfer. It's compressed. When it's compressed at high pressure, it heats up more easily, and that is then how the heat is then exchanged. For doing a ground loop, typically you'd need to have about 700 square meters in order to get enough of a slinky through to actually get the heat transferred. If you're looking at a borehole, it might be that you'd have to go down as far as 100 meters. The diameter will be about 250 millimeters, and probably pretty much you could power a 5 kilowatt to 11 kilowatt system with two boreholes that were about 5 to 6 meters apart. Unfortunately, the ground source heat pumps are more expensive, and this is because of the case of putting the borehole in if you have to have one. A borehole can add between £4,000 and £5,000 to the cost of the installation, just for actually getting the borehole in itself. If you have loads of land where you can actually get the slinky in, you know, it's all well and good. It's the more straightforward way to do that. With the water source heat pump, works in much the same way. The heat transfer is actually easier in the water because as a medium, it's easier to then actually exchange the heat. And also they tend to be fairly stable around 5 to 8 degrees Celsius. But if you have a property that's close to a large pool of water, that's all well and good, lake or pond even, which some people will be able to. So, and another example actually would be like a farmhouse might be another area to have your water source heat pump. Depending on whether you have the open loop or the closed loop system, you do need to actually have permission from the Environment Agency, because these can work either with a mixture of a heat exchange material, or it can actually take water all the way through it to then exchange the heat. I think, yeah, there we go. Well, this is the end of where I got to with the slides that there are. A bit of a pace. Hopefully afterwards everyone can have a read of the slides, and then if there's any other specific questions, by all means drop me a line and I can get back to you. Just a very quick whiz, reference information, an acronym buster for those for other presentations, just a rough gist of a hybrid heat pump setup, as I was interested in that. These are the more common hybrid heat pumps that are available. Daikin and Valiant seem to be the leaders at the moment with selling the most from what I've seen when I was looking around. These are a list of the heat pump manufacturers. I have put these two details in because during the last webinar that I did, I was asked if there was any suitable for harsh environments by the coast. And these two are the only two that I can actually find that are actually suitable for being by the coast. And then again, some other websites with further information. There is a myth that heat pumps now are very noisy. 15, 20 years ago, yes, they probably were. But this one here at Busy Energy, you can actually hear the gentleman talking over the top of the heat pump that's behind him, and it's very, very quiet. And here is the information about the Eastern New Energy project, but I won't bore you all with that as we are now. So there we go. Thank you for listening.
Thanks, Warren. So we're getting quite a lot of questions and chat going on. And there's been a bit of a discussion. It started off by Bart, really, who's playing devil's advocate. Bart, would you like to tell us what you were thinking?
Oh, I would love to. Of course, tongue is firmly planted in my cheek, but why would I want a heat pump? They're expensive. I need to overhaul my heating system. Hot water recovery, which we didn't talk about, is probably not as good. And they cost a lot of money.
I agree. I'm actually here really to explain what you're going to find if you have one. It's interesting. They're going to be like solar storage and PV. Prices have halved over the last few years. I'm sure they will get better. It's also worth mentioning at the moment, the renewable heat incentive has been extended for 1 year before it's going to morph into another scheme with the likes of the Green Homes Grant and other areas. Whether it's physically going to be possible to sensibly afford one or not, I don't know. In fact, I don't think anyone will do, not for another 6 months or so.
I'm happy to comment. I have a heat pump, Bart, if that helps.
Yes, please go on, Ian.
Yeah, by the way, I'm not here to sell heat pumps. I would start by saying, and I think you've suggested this, first steps to reduce energy demand in the home. So there are some very practical things, as we all know, about to reduce energy demand in the home. But if you get to a point where you think you've actually achieved what you can on that very, very important part of the decision making, then deciding how you're going to heat the home is the next question. gas currently has a CO2 per kilowatt hour, which is, when you look at the factors of the coefficient of puffs on a heat pump, means that in a home of 3 bedrooms, you probably can take 2 tons of carbon dioxide out of emissions. And I think the question of expense is a view on your view as a citizen on the value of carbon or the reduction of carbon.
Thanks, Ian. Maybe I'll call on Sue Ginsberg. You were interested about where else you could install heat pumps. You
Yeah.
able to go ahead?
Yes, not that we would necessarily be thinking about it now, but other than homes, what about ancient buildings? What about churches? And you know, I think you did mention stately homes at one point, but I just wondered. I'm interested in what you would say.
But yeah, I mean, they can be, and they have done. In fact, there was a gentleman on Grand Designs that bought an old castle, and he put 4 ground source heat pumps in there, and he said it was working very well. It really is the mechanics of where you run your pipes to, and then where you actually position the exterior compressor. That would be the hardest thing to think of. For churches, I mean, if you've got high volts, vaulted ceilings, and specific where heat can run up, if you're going to have, or if you can manage to get some sort of fan up the top to spread the heat around, wouldn't be too bad. But if it were something with solid stone, like a church typically, I would also give some strong thought to infrared heating. Because the other thing is that with it being stone, it would actually soak up the heat and then release it over time. And it's a matter of making sure that it fits in with the surroundings as well. I believe you can actually get a circular infrared tube heater, and there was one company had them designed for church pews, in actual fact. So you can actually put it underneath the pew that they're sitting on to try and keep people warm.
Okay. Thank you.
Thanks. Okay, well, we'll have one more question in this section. So, Tony Russell, are you up for giving your question?
Yeah, we're at the moment looking at getting a heat pump installed to replace our 40-year-old gas boiler, and looking at the possibility of doing solar PV in conjunction with that to provide hopefully a good amount of electricity to run the pump. Do you have any thoughts on that as a combination?
Yeah, no, I think that would be a good idea. There has been a lot of talk over the last couple of years about tariffs changing. So a day might end up with multiple tariffs, 4 or 5, to encourage people to use less energy at certain times of the day. If it's affordable, I would certainly consider having some battery storage put in at the same time as the PV. Certainly, I know an air source heat pump is being looked at as very favourable to people that are off gas, and especially in rural areas where the energy supply might be difficult with the battery storage setup. Certainly, I would imagine the heat pump should be relatively low on the energy draw compared to other heaters, so you could get a little bit longer out of it with the PV and with some battery help as well.
Sorry, can I come back on the battery? Because that's something I suppose in terms of the overall impact on the environment, that's not actually going to have a positive effect, surely. It may save financially a bit, but you know, if the electricity is going to be generated.
I mean, interestingly, and I can scare the life out of you now as well. In my R&D channel that I had, I saw an article about people developing nuclear batteries, where they're actually going to use nuclear waste, and it has the potential to last for about, I think it was the 260 years, which is coming through. That being said, being a bit more just around the corner, the majority of the batteries that go in the home are actually the repurposed Nissan Leaf batteries. They can only be used in the car for a certain amount of time before they then actually lose their performance. And then they're repurposed for domestic storage, and then I believe can actually be fully recycled afterwards.
Early.
So Tony, we will have a event later on your smart electric home, which will give you much more information about batteries.
Thank you.
So for now, let's go on to our next section where two homeowners are going to tell us their experiences, starting with Michael Goodhart. I'm going to, shall I share your slide there, Michael?
Yep.
I think you should see that. Is it coming up okay?
Closed chat. Yes, this is a house we built in 2012. You can see on the right-hand side behind the trellis with honeysuckle growing on it, the air source heat pump. And if you go to the next photograph, what I was told was that air source heat pumps are as efficient as ground source until you get below about 7 degrees centigrade, and then their COP, coefficient of performance, reduces. And that's when we, in the evenings, light our very efficient wood-burning stove to supplement so that the heat pump doesn't have to work so hard, and to make the house nice, warm and cozy. And the photograph shows the log store at the back of my potting shed. And the next photograph is a close-up of the outdoor unit. It's a Dakin Alferma unit. And the next photograph.
Sorry, I don't seem to have got the next one.
Well,
I thought I had 4.
that would have shown the rather packed indoor plant room, which has the indoor unit, and under it.
Oh, sorry, here it is.
Yeah. Under it is the hot water cylinder, and on the right-hand side is the solar thermal controls. We have a couple of Velux panels that heat hot water, as well as extensive photovoltaics on our large sloping south roof. And below that, you can see the manifold for the underfloor heating system. And our air source heat pump is serviced annually. And what lessons have we learned? Well, the main one is the importance of getting the system correctly commissioned so that it coordinates effectively with the other building services, such as the solar thermal. And it took several years before things were set up correctly. For example, clearly, if the sun's shining, you want the hot water heated from the thermal roof panels to take precedence over the air source heat pump heating the water, and that wasn't happening. I would say beware of being fobbed off by installers who may be inclined to take shortcuts or may be reluctant to admit to and correct their mistakes. Perhaps the most effective way to reduce energy consumption would be to help homeowners to fully understand their heat pumps and how to make best use of them. If building managers were incentivized, this is perhaps for hospitals and schools, to manage their buildings so that the clever systems installed are properly used, then I think the carbon footprint of many buildings would be very considerably reduced. So if anyone's got any questions, that's a sort of summary of where I am.
So thanks, Michael. I think we'll hear from Anne next and then take another round of questions for anyone who's spoken. And so next, Anne Miller, full disclosure, she's my wife, is going to tell us about our heat pump.
We've got a slightly different system to Michael, which is it's an air-to-air heat pump. And we were inspired to get this after we saw what Tom's brother in Tasmania has, and just thought these seemed so simple. And for our situation, we thought this was really worth a go, but it won't be right for everybody. So I've put the details of the precise name of it on here. It's a Hitachi. It's very, very few of them in the UK. I think we might have been the first or second installation, but they're very common in Germany and France and places. So most of the instruction manuals seem to be in German. We got it from Anglian Energy Solutions. It's only got a 3 kilowatt output. And this photograph here, you can actually see it mounted above our back door. And what you see in my hand is the remote control for it. And you might think, that looks like an air conditioner. Well, it's in very small print at the top, so hopefully you can't read it, but actually it is both an air conditioner and the heat pump. But we have promised ourselves that we're not going to use it as an air conditioner, because that kind of negates the point of putting a heat pump in to reduce our carbon emissions. One of the nice things about it is its coefficient of performance is 5.1. If we were in Cornwall, where it's a little bit warmer, it would be more like 6.1. That's probably double the minimum. Well, I mean, slightly more than double, better than double the coefficient of performance, which is sort of like the efficiency that Warren mentioned, that had to be at least 2.5 for an air to water system. And the reason for that is because all it's doing is blowing out, wafting out a stream of warm air at say 20 centigrade. Whereas an air to water pump, heat pump, as Warren said, has to heat the water in your central heating to probably at least 40 centigrade. So the heat pump's got half the job to do, pumping the heat up in temperature, and so it's roughly speaking twice as efficient. This particular one's got a refrigerant called R32, which is very efficient, and it's got low what's called global warming potential. So if any of it leaked, it does less damage than the normal refrigerants. And the final really sort of remarkable thing about it was that installed, this was 2.2K, 2,250. And it was installed in a morning. It's very, very simple to install. The external unit, a bit like Michael's one, but rather smaller, is just here. And this is many, we live in a Victorian terrace, typical kitchen room. The key thing about this is we just wanted to heat the one room, because in general, the rest of our house is kept nice and snug by our neighbours, and it was just this kitchen area that gets cold. We're just in the middle of installing external insulation, and we've put a whole load of triple glazed windows in there as well to reduce that. We looked at, we've done some monitoring. It's been in for just over a year, went in just before lockdown. And we think it's using about half to a third of the energy that we were using for central heating. Again, we were mainly heating just that kitchen extension. And for the geeks amongst us, we also wondered whether it was, as Warren said, in general heat pumps, you have them on longer and lower, and so we sort of plotted the graphs of how much energy are we using. This is the kilowatt hours we've used each day, and here's the hours clicking through the day. So this is 12 hours after we switched it on. And it can be just on gently, or if we turned it on for a quick boost when we had some coffee, and then we went away again, and then we turned it on again when we came down for another cup of coffee, it actually didn't make much difference to the heat demand. Whereas for the central heating system, you can turn it on and off, I think, much more effectively, which is something we were in the habit of doing. So we've changed our habits about how we use the heat pump in order to use it more effectively. And so really, as a sort of summary of the advantages and disadvantages, just say, I think this air-to-air one, it's about twice the efficiency of air-to-water heat pumps. it's about a quarter of the cost, though that doesn't include the benefits of the renewable heat incentive, which effectively gives you your money, most of your money back over 7 years. It's also very compact. I mean, it's just this box internally and a small box outside, which for some people, is quite an advantage. The disadvantages is really it's only suitable for one room. We're going to experiment next winter with seeing, when we've got our kitchen well insulated, whether we can waft heat up the stairs from the kitchen, which I think we may well be able to. You can get ones which have 3 separate units attached to the one, so there are 3 rooms, but I think that's probably beginning to negate the advantages of simplicity. Of course, you don't get the renewable heat incentive. And I think that's probably because the government doesn't want to promote them out of fear that people will use them as air conditioners, which would, of course, make everything much worse. Another thing is, of course, this doesn't heat water. So you need some other way of heating your hot water for your shower, for your kitchen tap, for your baths, whatever. Of course, that could be an immersion heater. There are other sort of, direct, or it could be an electric shower. It could be a direct thing under the kitchen sink. And there's no heat storage, which is, of course, another useful way of evening out the heat demand and stuff. In terms of what we found, I mean, Michael commented about the noise. The internal unit we find is basically completely silent unless we turn it on real sort of boost mode. The external one, it does thrum a bit. Yeah, it's not deafening, but our next door neighbour did comment there's a sort of slightly industrial noise when it goes through a sort of resonance point, as it's sort of revving itself up, particularly on a sort of cold day when it's below about 6 centigrade. But in general, we're very, very happy with it. And I think, for some applications, particularly small homes, it could be really quite a good simple solution.
Thanks, Anne. That's good. So there's lots more questions coming in. Can I call on Alex Jelly? You had this interesting question a while ago about cold liquids.
Thank you, Tom. Yes, so does anyone know whether I've been told it spits out freezing water? Is that true?
From where exactly?
I don't know. I suspect it was a scare tactic.
A heat pump.
Heat pump. Yeah.
I mean, what I've noticed in ours, and Michael's probably found the same, is that there is quite a sort of chilly breeze coming out of the external unit, because of course that's it's been sucking the heat out of your garden to put in your house. So it's definitely don't plant any shrubs right in front of it that mind being a bit chilly. But I mean, I guess occasionally it might drip a bit, but I don't think it would spit out freezing liquid unless there's something seriously wrong with it.
In fact, at Mitsubishi, where they do the training courses, part of the exercises, they run a heat pump and close the door in the training room to let it get really cold. So I think it would be safe to say that if there was any risk of anything freezing coming out, they certainly wouldn't be doing that. But yeah, apparently it brings home the importance of having lots of space.
And so, okay, could Anne and Miller, do you still use gas to heat water?
Yes, we do. So we've spent ages, dithering about heat pump, because like some others here, our gas boiler is aging. It's still working fine until it stops working fine. It's about 20 years old, but really it was a top of the range combi. And so, as Warren said, you hear about hybrid systems which use a bit of gas for when it's really cold or for heating hot water and a heat pump. And we thought, well, in a sense, this is a sort of DIY hybrid system. So we've got the heat pump which heats our kitchen when it's a bit chilly in the winter, and then we use our gas boiler for heating our domestic hot water. But if that boiler suddenly died, we'd probably replace it by a direct electric system. And then in the evening, when it's in the winter and when it's cold, we use a wood fire like Michael does in their sitting room. We just snuggle up amongst it.
So Dave Fox, you had a question about space needed?
Yeah, thanks. A question for Warren. Thanks for your presentation. You suggested the internal space of about 2 by 2 meter floor area and 2 meters high was required for a heat pump. But you also described monoblock and split systems. So does that space measurement apply to a split system? My interest is that I'm designing extension where I'm going to have a heat pump supplying underfloor heating and possibly first floor radiators, and definitely the hot water tank as well. So I'm going to need to arrange internal space somehow, and I need to know how much I need.
Yeah, I mean, really, it's going to depend on the size of the tank that you want for the water supply. Typically, I think it's about 25 litres per person per day is generally what's allowed for. One thing might be worthwhile doing is to consider one of the sun amp boxes for some of your hot water. As I've been reading more of the text that they've sent, and I honestly say I'm not a sales rep for them either, but their boxes are actually quite small, and some can, what I would class as a average larder fridge, they reckon can heat 310 litres of water. So that was quite a considerable space saving if the calculations and everything else are correct. But really, it's try and aim for as much room as you can, simply so if anything needs to be done on it, you're not trying to squeeze around corners to get to pipes and everywhere else there is. But I would have said take your average typical airing cupboard. If you could get double the size, that should be enough to have a cylinder and all the bits that you need in.
I might say that I'd probably break all the rules, but I managed to fit it all in a space of about a meter width and meter depth and 2.4 meter high. It's all packed in quite a lot, but it does work. I haven't had any problems due to the tightness of the space, although some of the engineers installing made certain comments. One of the things I think is doors that are full height, 2.4 meters high, and that means that you can get access by opening the doors to everything is in front of you.
Yeah, I think a great deal was stemmed to how good the engineer is who's installing the pipework. I think if you have a really good engineer, then yeah, you can bring the space down as long as they have a really well thought out map for where all the piping is going to go. Then yeah, it should not be too bad. But generally speaking, if I were to say to someone a metre square will be fine, and they get an engineer who's not quite so hot on the pipework, then I would get my knuckles wrapped.
So Bart Hummels, you had some interesting points to make about heat stores.
Well, there is talk about battery systems, but I guess it only goes for well-insulated houses with big thermal mass. But if you're doing extensive refurbs, you could consider one of these things, or a huge water tank will do as well, where the heat pump actually just heats a large volume of water during the time when electricity is cheap, and that you can then run through your radiators or your underfloor, preferably when electricity is very expensive. So basically in the slot between 6 and 9 in the evening, you switch off your heat pump and you run it from the stored heat.
If I just jump in there is a brand new product that I've seen only within the last 2 months called a Caldera heat battery. I think Ian is aware of it as well. I can only describe it as it's like a supersized oil drum, and it's designed to run, have the hot water up to about 400-500 degrees permanently. It can be added to with a solar thermal, and then they've had a pump fitted to it. This is a prototype that they've put in a 1960s house. Well, I say in the house, it's actually in the garage because it's far too big to get in the house. What they're saying is it's so hot, they have to let it cool down for a week before they can actually work on it, or else it's too hot to touch. And they're in the process of doing crowdfunding at the moment, but I would say that's a product to watch for the future. They're actually testing it on the owner's house, and the webinar he did on Cambridge Clean Tech was showing that it was working relatively well.
Yeah, can I make one more off the record, well, maybe on the record comment about storage tanks for hot water? Be very careful where you site them, because ours is next to our bedroom and it's fed from solar thermal. and in the summer when there's lovely lots of free energy, it does bleed quite a bit of heat into the bedroom in the summer where you really don't want it.
Thanks, Bart. That's a good lesson. Well, Alex Jelly, would you like to ask your question about maintenance?
Sure. Thank you, Tom. I'm asking this to Warren, but other people might know. Should I be requiring my installation company to do an annual service?
I would have said so long as they're MCS qualified,
Yeah.
anyone should be okay to do that if you want to have the relationship with the people that installed it. You're all well and good. And if I can also just quickly jump in, something Michael mentioned, I think it was about the controls. It's more common, I'm told, than you would believe, that some of the installation engineers don't set the timing controls up correctly, and they might do a Legionnaire heat up perhaps once a week instead of being once a month and so forth, which can then use unnecessary amounts of extra energy. So it's also ensuring that the controls you have are easy enough to understand, and then that they're set correctly as things move on.
Thanks. I think we've got time for just one more question. Stuart Charnell, do you want to ask us about pipe work?
Oh, can you hear me?
Yep.
Oh, good. So I'm trying out this headset. Yeah, I mean, my central heating system at the moment, I guess, has got the standard, well, not it's got the small capacity thin pipes. I guess they're kind of like probably 8mm, 10mm plastic.
Yeah, that's
so,
the micro bore, which is around about 8mm, of which the bottom of my house has got it all the way around it.
Yeah, so I'm presuming that, I think you said earlier on that you'd need to replace that, or that wouldn't work with a...
No, there is potential that it might just work on a 16mm diameter pipe work, but it could cause issues to the pump itself as it's pumping the water around. Not only that, you need to get the extra flow to go around as well to get the heat into the radiators. So really, you'd need to be looking at around about 20mm diameter pipe work, which is, it's the other reason why I'm myself am not rushing to go and get a air source heat pump, because I would have to have all the walls chipped out downstairs in the house, and literally everything pulled out and then all put back in again.
Right.
Well, thanks, Warren. I'm sorry we haven't answered everybody's questions. Remember, Warren is offering to, you can email him later if you've got something outstanding, and that will be in the slides that we circulate soon along with the recording of this. And so thanks to Warren and Michael and Anne who've spoken, and to you all for being here. Can I just give you one more quick poll? I'm asking, has this talk made you more likely to create an eco-home? I'm not being that specific about what eco-home means, but could you pick one of these that answers that question? I'll give you a little longer. Oh. For some reason, it says the polling has closed. I don't. All right, let me try again.
I just hope I haven't accidentally clicked on
Okay.
something.
I've relaunched it, but I'm not quite sure.
Yeah, I think that was my fault, Tom. You made me a co-host, and I think I tried to vote and accidentally ended the polling.
Okay. All right.
Sorry, folks.
Well, let's. I'm just going to. Can you screen grab this result? And okay, I'm going to end the polling, but to say the huge majority of people who have said that yes, they are. Oh, I share the results. As you see, 2/3 of people are saying yes, this has made you more likely to create an eco-home, which I'm pleased with. So R is up nearly. If you still have, so we're going to finish this meeting on time as we usually do, but if you do have further questions or experience to share, we're going to stay around a bit, the speakers, just in case you want to have a bit of discussion. But thanks very much, everyone. This is now the end of this main talk. And oh, I know, I was going to show you one more other thing, sorry. This. And I just do a screen share. And so I was just going to plug the fact that Cambridge Carbon Footprint have a mass sign up for the Cambridge Climate Change Charter, which we're running for the City Council next Saturday on World Environment Day. And I'll put the link to this in chat. And I was going to say that most of the Open Eco Homes talks and tours will be in the autumn, as we did last year. And we're going to keep you up to date with that. You can go on Open Eco Homes website and sign up for email newsletters to be kept up to date on that. And this is all run by the charity Cambridge Carbon Footprint. And so it would really help us reach more people to involve them in cutting their carbon footprints. If you want to make a donation, here is the web address. Thank you very much. So that's the end of the main session. But stop around if you want to ask more questions.
Can I just make one point? With regard to air source heat pumps or heat pumps for retrofit, it's a very complicated solution. And I think everyone would agree that retrofitting an old house to make it eco, the first thing to do is to improve the insulation. And then I think there is an alternative way of heating your house that is valid and should be considered. And that is to use electric heaters. Now, they won't have a good coefficient of performance, but one small electric heater in each room is going to cost about £150 each with its thermostat and all the rest of it. And for a small house, well, the installation cost is so much less, and the requirement for space for equipment and all that. And the other thing to bear in mind is that with renewable electricity, the difference between peak and off-peak electricity prices is diminishing all the time. And a lot of suppliers are encouraging people to have just one tariff at a very competitive rate. So if your house is extremely well insulated, a small electric heater in each room is a very much simpler way to heat your house, and probably doesn't use a huge amount of electricity.
I've also heard of people heating with, I mean, the trouble about direct electric is unless your house is extremely well insulated, the actual kilowatts hours that you need adds up to a really horrendous electricity bill. But if you've actually managed to absolutely slash your heat requirement, I think it's really neat. And I think I've heard of one place where they had direct electric heating a tank full of hot water, a large tank, overnight, on the sort of lowest carbon, lowest price electricity, which they then ran through the radiators and stuff during the day.
Warren, were you about to say something?
Well, I mean, I have a strong like for the infrared heaters. If you take your standard convector, if you like, 1.2 kilowatt, you could probably replace that with somewhere in the region of a 300, 400 watt infrared panel. And then you might actually knock your heating cost down to only about a third as what it will be for a convector. but they work in a different way, and it's the way in which all the heating works differently. With radiators, you get convection, so you've got that chance of actually moving dust about as the hot air warms up, moves and flows. With infrared, it's a direct emission, so you don't get the same air movement that there is. But again, it then also depends on what sort of property that the heaters are in as well. So I think it's horses for courses, as the expression goes, and it's going to be the older, harder to treat ones from the insulation point of view, which I think is going to need the focus. Two other snippets I've got from talking to the industry just recently is that, for one, with the announcement that the International Energy Group made, there is now a mad rush for people going out to buy gas boilers because they're convinced that they're all going to be taken away from them in 2025, which has not had the effect they wanted it to. My heat pump guy said that the manufacturers are actually tweaking gas boilers now so they can actually run on a certain amount of hydrogen, as there's still moves to go towards mixing hydrogen actually into the national grid. But at the same point in time, the cabling infrastructure has not been increased sufficiently if you ever want to go onto a heat pump yet. So it's going to be a need, I think, for a combination of different measures in order to get everything moving forward.
Thanks, Warren. Can I call on Peter Danson, because I see you've got a Mixergy energy tank store. Are you able to tell us a bit about that? I'm not hearing you, Peter.
What sort of things did you want to know?
Well, you were saying it's very efficient, and you described how it worked very briefly, but
so it's an immersion tank, and it actually heats from the top, and it uses stratification to keep the cold water separate from the hot water, and it heats very efficiently. Uses a disc rather than sort of pipe work within the tank. It has very granular control, so you can say, I want 30% or 35% hot water. It's all internet controlled. They call it the Internet of Tanks, and it's subject to grid services as well. So the company, if you sign up for that, so the company can actually trickle some electricity in if they wish to heat during the night or at low tariff rates. It follows Agile. It can follow Agile if you sign up for it. So it uses Agile tariffs very efficiently overnight, and it has a PV diverter built in, and can use a heat pump as well, although we haven't got a heat pump, and we do have a PV diverter. So days like today here in Cambridge, and yesterday and the day before, are great because we get 100% hot water, a tank full quite easily by lunchtime, just off a small array of PV panels. They're a very interesting company, quite forward-looking, and I think they're trying to get into those housing areas where housing developments where they just put these tanks in rather than ordinary immersions. We went to it because our immersion failed, and we just thought it'd be a good idea to replace it, the whole tank in one go, and it works really well.
And Warren, other people have been asking about the necessity of having underfloor heating, underfloor to go with SOS heat pumps. Any comments on that? Is it necessary to have underfloor heating?
You don't have to. It's just that the temperature that the water comes out of the heat pump is ideally suited for underfloor heating. I know there are many trains of thought as to how good underfloor heating is. I think it just depends on the level of control that you have over the zones in the underfloor heating. Like some people prefer warm air underfloor. It's that just, but from a mechanical point of view, yeah, no, underfloor heating is a really good match, but it can be done with radiators and it can work quite well. It's just making sure that if you're doing a refurbishment, that there is sufficient room for the bigger radiators to go in, rather than a new build, where it would be a bit easier to arrange the layout of things.
We're having, I mentioned we're having some radiator, we're having some more insulation put in our back area, but in the process, you know, one radiator came out and we're just replacing it with a bigger one. Not because we, you know, in theory we don't need it, but the feeling that maybe we'll end up using a lower temperature wet heating system at some stage. So one of the ones, it looked a bit like one of the ones that Warren was showing on his drawing. So I think if you're replacing radiators, you know, go big just in case you end up deciding you want a heat pump later.
Well, and actually, that reminds me, if anyone's thinking about going for a hybrid heat pump system, do choose radiators very carefully for when, if you've got the perfect size for a gas boiler, then it could be a little bit chilly when using a heat pump and vice versa. So again, it would be worthwhile to go bigger to make sure you're well suited for either heating source.
Michael, will you go ahead?
The imperative with underfloor heating is under the underfloor heating, you've got good insulation. Otherwise, the response rate is very low and a lot of heat gets leaked. It might also be worth pointing out that Wimpole Hall has put in, at vast expense, a ground source heat pump system to heat their mansion. I shudder to think how many years it will be before it repays itself. But that's an example of a large building using ground source heat pump.
There's a lot of good things in chat, people making suggestions and so on. So I will copy all this and circulate it. But I'm not seeing many more actual questions. Or is anyone else burning with a question?
Hi, Tom, it's Ian.
Hello. Yes, hello, Ian.
Hi, Warren, could you just clarify, you know, the conventional gas boiler, combi boilers have removed the hot water tanks often from the home. Could you just clarify, so everybody's clear, the fact that you do need a hot water tank, yeah, in terms of use of space?
Yeah, I mean, because with the combi boiler, that will provide you with hot water out direct, but I'm also aware of a lot of people having issues with the wastewater from a combi freezing over winter because it's not been well insulated. Otherwise, you'd be like me, where we have a gas boiler and what is sort of like a system boiler. So it actually fills the hot tank up with water, or the cylinder up with hot water, and that then does hand washing and washing up and all the other bits, as well as the heating. But yeah, so really and truly you would need a cylinder somewhere to have a supply of hot water, and in particular, if nothing else, in the event of power cut, to make sure that you've got hot water that is saved somewhere for use at a later date or later time even.
And just as a follow-up, and I'm conscious trying to cover so much ground in such a short time, Warren, but are you aware of whether the mixed energy water tank is compatible with heat pumps?
No, I don't actually. I wasn't aware of the mixer energy tank. The Sunamp product is compatible with some heat pumps, but it depends which particular product line that they have.
Yeah. Okay. Thanks.
I literally will have a look at the mixer energy, and then I'll get back to you.
Yes, Mixergy, it's called Mixergy.
Mixergy, yeah.
Oh, Dave.
I've put the link in the chat, Warren.
Right.
Yeah, I've just copied it. I'm about to paste it into the internet browser. Thank you.
Go ahead, Dave.
Question for anyone really. So I'm planning to have underfloor heating run off something like a 5 kilowatt air source heat pump. The only other heating source I've got is a very small wood burning stove. I'm just wondering whether I can get away without having any heating for the first floor bedrooms, other than occasional use of electric heaters, like Michael suggested. He's gone, but like Michael suggested, they're increasingly low carbon because the grid's decarbonising. And I don't actually need to heat those rooms very often, maybe just a few weeks each winter. Is that a feasible solution in a well-insulated house?
My feeling is yes. I mean, you know, particularly, with a well insulated. I know you've insulated. I mean, my first house, there was only a little heater downstairs, little 2-bedroom terrace, and I had a door on the stairs, and I opened or shut the door to keep the heat in the sitting room or let it waft upstairs. And as you say, often you don't actually, the heat's rising anyway. And on those exceptional days when it's below 0 outside or something, and you want a little toast, or you get yourself an electric blanket or something, some people might say, well, the air temperatures are too low, but in general, people find it more comfortable sleeping in cooler air with warmer bedding. I think it sounds like a really good idea. Might just be a personal take.
Michael Goodhart, can I just ask you about the electric heaters that you suggested, maybe only £150 each? Are these like portables that you bring out as and when during the winter, or are these fixed installations?
No, I'm thinking wall fixed. They look rather like radiators. What made me start thinking about this is a niece of mine has bought a ex-council house in need of thorough refurbishment. And she was saying, oh, what about an air source heat pump? And I just went online to look at the type of electric heaters that are now available. And there are very smart looking ones that you fix to the wall, and you just need a spur. And you have ones with time clocks if you need that, or others that operate thermostatically, or both. It just seems to me that if you've got a 3-bedroom house with 3 rooms upstairs and downstairs that need heating, then it's just so much simpler than all that is involved with retrofitting a heat pump for heating in a house.
And sorry, it's Ian here again, Dave and Michael. I think Anna's mentioned it as well. If you look at the house as various zones, one doesn't necessarily have to have a solution that covers all zones. So even Dave, in your, I think you mentioned you were going to put underfloor into one part of the house. Certainly I've done this in a property of about 50 square meters. I've just used a very direct electricity boiler to heat the water to run underfloor, and the efficiencies are good. The costs are very low in terms of installation, and it performs very well with the if you're putting in floor in. So I think taking a zonal approach to the solutions might actually lead to a much better outcome, and certainly not necessarily all the costs that we've just discovered. And indeed, I would suggest some of the risks of engaging with contractors who are, I think, at a very early stage, I'm being very polite here, very early stage of understanding. This government and previous governments are not training people in the way that we would like. And people are finding it, certainly from my experience of installing in 2011, one had to sit on top of the contractors and get them to come back to check the controls. So again, there are significant pitfalls, I would suggest.
I found there was a division of responsibility. The installing engineer was not able to commission the system, so they brought in someone else to commission it. And then when it wasn't working, you weren't sure who to call on. And I got sent around the houses trying to get the system working properly. But hopefully things are improving on that line. But sometimes I think sometimes these subcontractors just want to get in and out as quickly as possible, and will take shortcuts, which mean your system is not working as designed, and is far from as efficient as it ought to be.
My brother's, quite a tech geek, and frustrated by the sort of lack of efficient installations in so many cases. He's actually just qualified as MCS installer, and has been doing a lot of work, so working out the sort of, you know, the optimum installation. And one of his realizations was that in very many cases, the installers seem to bung in a system that's about factor of 2 oversized. I mean, he has one in his own home, which he now realizes is probably a factor of 2 oversized, which meant that then all the pipes had to be replaced. And I think it was, you know, they had to go up to 22 millimeters diameter pipes or something, which was incredibly disruptive and expensive. And the heat pump doesn't work as efficiently as it would do if it was correctly sized. And so, you know, the frustration out of that process has meant him start to, you know, see if he can do it better. He's just done his first installation on somebody who's a sort of brother-in-law, as it were. So it's in the family if it doesn't go well. But you know, his feeling is that you know, there's an enormous amount of cost to be taken out of the system. At the moment, there's a lot of sort of, you know, faff in there because people don't quite know what they're doing. And they don't want to get complaints that people are cold, so they put in a system that's too big. And I'm sure that obviously there are some installers that know what they're doing and do a good job. And we've been pretty happy with Anglian Energy solutions with just our air-to-air one. I can't comment on what they'd be like for an air-to-water. But you know, things will get better later. But on the hand, we need some people who are prepared to be heroes and, you know, start now in order for things to get better later. I don't know if you've got any thoughts, Warren, about whether some people tend to oversize systems.
Yeah, it is. I mean, I got made, was on furlough, got laid off. So the heat pump contractor chum of mine actually took me in and started training me up and actually gave me some work to do. It's all too common. There are lots of people just want to rush in and rush out, not do a proper design, which then means, yeah, they certainly won't be as efficient as they could be. It's just the nature of the industry, I think, for a small side of it with what they're like, which is why, yeah, making sure that they're all fully qualified and actually can demonstrate with some experience or references even.
Well,
and also, if just say quickly,
yes.
to Dave, I've known a lot of people that have had underfloor heating. Every single one of them have said that they've gone around and turned all the heating off upstairs because they never needed to use it, because the downstairs heated through the entire house. And there's loads of people that tell me that.
That's very interesting. Thanks, and thanks also to Anne and Michael for their answers to my question.
Well, thank you to everyone who's participated. I think I'm going to draw it to a close now. We've gone on for 20 minutes extra, and we could go on longer, but not indefinitely. So thanks very much for participating.
Just ask Warren again, can anyone do the maintenance of my air source heat pump? Or does it have to be the MCS qualified?
Get MCS qualified to come and do it.
But it doesn't have to be my installer.
No.
I might say that I'm now on my 4th or perhaps 5th annual servicing engineer. They disappear, they don't reply to emails, or they're just incompetent, I don't know. So it's a bit of a nightmare there.
Our installer told us that we needed an annual service, but basically all they did was clean out the leaves and the spider's web. So I thought we could probably do that ourselves, at least for a bit.
Did you have to pay for that, Anne?
No, that was when he installed it. He said, well, in a year's time, you really ought to pay to have a service done, which was going to be 100 quid or so. I thought, well, you know, that's quite a bit, adding quite a bit to the economic costs because it's quite a small system. But anyhow, I mean, I decided that I could take a brush to brush out the leaves and cobwebs from the back of the external heat exchanger.
I was told, and Warren can tell me if I'm right, but one of the reasons for the annual service is you need to service or check the refrigerant gases. Is that correct with a heat pump?
Yeah, well, it depends. In the monoblock, not so much. In the split unit, yes, it would be more so because you've got more chance of a leak. But yeah, ideally they need to be kept an eye on because it is an offence to allow it to get into the environment, and you have to be a suitably qualified person to actually do anything with the gas.
That's what I understood, Warren. And you don't get your RHI payments if you don't have it annually maintained.
But I
Is
think
that right?
They haven't asked me that.
with the RHI, I think there's supposed to be an annual report that goes in, and if you miss one, then you run the risk of losing your money.
Well, you just have to confirm that that the house you still own the house and that you're still using the system. That's all I have to do for my RHI payment for the air source heat pump and for the solar thermals.
Thank you, Michael.
And we're not eligible for RHI, which is why I wasn't aware of that.
Okay, well, there's lots more to say, but I think we need
Thanks,
to
guys.
stop now.
Been really
Thanks very
informative.
much for joining in.
It's been a real
Bye-bye.
pleasure. Bye.
All the best.
Thanks,
Take
everyone.
care.
Right.